Good morning, everyone. Today we continue our discussion on second part of the course, which is analytics part. Uh, and then we start first hands-on experiences in analytics. And as we go further, you can understand that our focus is more on hands-on experiences. So and we have some textbooks and other materials to help you to understand some basics, but our focus mostly on how you make everything done. So you should be able to do some analytics, either descriptive and predictive or prescriptive. And at the end of semester, most of your grades coming from what you do, although you have some quizzes and some exams, but the vast majority of your course credit and understanding is coming on how you can perform analytics. Okay, having said that, in the previous class, just a little bit of the content remained. Just let me go over PowerPoint and then we go over Knime and start our first hands-on experiences. Okay, two things just keep in mind. One of them is multicollinearity. Basically, in the predictive section of your course, you try to predict your dependent variable. Your independent variable is better to don't have any correlation with each other. If your dependent variable has some correlation, it might, at the end, you may not be able to describe your model well. For example, let's say you want to predict the house price. So you look at the Redfin or Zillow or other website, you see that there's some information about houses. One information could be number of rooms, another one maybe like a square feet, and other one might be let's just focus on these two. So number of rooms for sure is related to the price that we want to predict. Also, the square feet area is also related to the price. They are very intuitive. Also, there is a correlation between number of rooms and square feet. So if you use both of them in, let's say, in a statistical model or white box models, one of them may turn out to be insignificant, which is not intuitive, because both of them should be significant in the price value, or some of them could have positive or negative signs. For example, your model might say more, your final equation might say more rooms, less price. So the reason for having such a counterintuitive equations is the multicollinearity between your independent variables. So when you want to use white box models or a statistical model, just keep in mind having a correlation or multicollinearity between your independent variables may affect your final equation, may not be very intuitive. I'm pretty sure you might have this in your statistics courses, but unless you didn't have, you can just watch some YouTube videos or just go back and review your some of your statistics course. Another one, just keep in mind, we have one causation and another concept is correlation. Let me give you an example. We want to look at a student grades when they graduate. So intuitively, if you study more, you have a better grade. But it may or may not be true for everyone. But if somebody study a lot, maybe they sacrifice a lot and they don't go to the gym, or because of mental pressure, maybe they eat more. So there is a good probability that they gain weight and their BMI is more. But doesn't make sense that saying that if you are heavier, you have a better grade. So, but there is a correlation between BMI and grade. Or if you study a lot, You may lose some of your eyesight, so you may have to use some glasses. So somebody study a lot might have a higher BMI or might have glasses, but having glasses doesn't make is not a reason for having higher grade. So but I think you can understand the correlation. So the cause for having higher grade is study more, but that thing might be correlated to other features. So let's say at the end you want to talk about your model. The way that your final project is, the way that you explain is through correlation. You shouldn't say this variable might be the cause of this outcome. May or may not. So our focus in this course is not just investigating causations, but so the way that you explained your final model is based on correlation. Let me share this video again. Let's see, where is that? So, share sound.
Hello, I'm Paul Henney and I'm a philosophy graduate student at Duke University. And in this video, I'm going to talk to you about correlation and causation. Maria and Andy are high school students in Arizona. Andy always gets an A on his math test when it's sunny outside. On one sunny day, before Andy goes to math class, he tells Maria, "I'm going to ace this test today because it's sunny." Maria objects. "No, Andy, you'll not ace this test because it's sunny. You'll ace this test because you studied. The fact that it's sunny outside has nothing to do with it." Andy responds, "But Maria, I always ace my tests when it's sunny." Maria replies, "Okay, sure, but that's just because you always study for your math tests, and it's always sunny here in Arizona. The sunniness does not cause you to ace the test." Maria's correct. Andy's making a mistake, right? The sunniness doesn't cause Andy to ace his test. The two events, the sunniness and Andy acing his test, occurred together without one causing the other. In other words, the two events are correlated in some way, but there's no causal relation between them. Andy's reasoning here is fallacious. Simply because two events are correlated does not mean that one caused the other. This conflation of correlation and causation is what we will talk about in this video. First, let's consider some other examples. Fido barks when his tail wags. People with higher grades in college have higher grades in high school. People who take vitamin C recover more quickly from a cold. These are correlations. That is, there's a correspondence between these events. For example, the dog, Fido, barks when his tail wags. But there's no reason to suspect that there's a causal relation between these events. While these events often occur together, there are many times when Fido's tail wags and he doesn't bark, and there are times when Fido barks but doesn't wag his tail. Furthermore, we may suspect that there is some common cause for these events, like Fido's excitement when his owner comes home. Now that we can agree that these are cases of correlation without causation, we can discuss two types of correlation, positive and negative. In the next video, we'll discuss how these types of correlation specifically relate to different types of causation. But for now, let's just introduce them. When events frequently occur together, like in the examples above, they are positively correlated. If two events are positively correlated, then when one event is present, the other is often present as well. In our first example, it being a sunny day in Arizona is positively correlated with Andy succeeding on his math test. On the other hand, two states are negatively correlated when it's likely that when one event occurs, the other will not occur. For instance, when it snows, it's often not very sunny, so snowing and sunniness are negatively correlated. We often hear about positive and negative correlations, especially in the news. Headlines like Taking vitamin C helps you recover more quickly from a cold, indicate positive correlations. Taking vitamin C is positively correlated with recovering from the common cold more quickly than if one had not taken vitamin C. Or headlines like, eating more nuts makes you less likely to have higher levels of bad cholesterol, indicates that eating more nuts is negatively correlated with having higher levels of bad cholesterol. You may have heard headlines like these and had conversations with some friends about them. And you may have heard someone say something like, awesome, so I'll just eat more nuts and get rid of my bad cholesterol. You may have also had the experience of someone else saying, yeah, but that's just correlation, not causation. Of course, this person may just be a jerk, but they are right to point this out. Unless you had evidence that a causal relation held, it is a mistake to suggest that this correlation is actually a causal relation. So it'd be wrong to say that eating more nuts will cause you to have lower levels of bad cholesterol, unless you had evidence that the causal relation held. So let's consider an example where two events are positively correlated when neither causes the other. Consider this again. People with higher grades in college have higher grades in high school. Here, earning higher grades in college is positively correlated with earning higher grades in high school. Now, it's incorrect, as we've discussed, to claim that earning high grades in high school always causes someone to earn high grades in college. Nonetheless, earning high grades in high school may sometimes cause a person to earn high grades in college. For example, Jane may have gotten good grades during high school, and some of those grades transferred to her college, which causes her success in college. Here, success in high school for Jane causes her success in college. But most of the time, it is not the success in high school that causes success in college. It is usually someone's working hard in college courses that causes that person to succeed in college. And at that type level of the statement, where we are identifying a correspondence of two data sets, the causal claim is false. So again, the two events, high school success and college success, are positively correlated, but they do not cause one another. When two events are correlated, it may seem that one causes the other, but there may be alternative explanations we've ignored, like working hard in college courses causes that person's overall success in college. So it's fallacious to conclude from only the fact that two states are positively or negatively correlated that one causes the other, because there may be another cause that explains the outcome. It may be that there's a common cause for both of the events, or that there's some alternative cause altogether. On the other hand, the correlation might just simply be a coincidence. But this explanation and other questions will have to wait for part 2, where we will talk more about the analysis of causation and how it relates to different types of correlation. If you're interested in these false cause fallacies, you may also want to check out our video on the post hoc fallacy.
So I hope now this video provide more example for you. So as you see in this course, our focus is on correlation. So you might take some quantitative courses that they are focused on the causation. So at the end, when you try to predict something, you're talking about correlation of factors to the dependent variable. Having said that, we want to focus on predictive part in this second part of the course. So please go to Moodle, week 4, class materials. I almost download everything. Also, you might remember that this from now up to the next couple of weeks, we focus on Knime. So, and as I explained in one of your earliest sessions, you should go download Knime. So for downloading, just Google Knime download, come here, make a profile, and just next download, and you can easily have the software. So I give you 5 minutes to download everything from Moodle, and also if you haven't installed Knime, Just please install it quickly so you can keep up with me. Otherwise, I upload the video later on Moodle, so you can, if you miss some parts, you can just go in the Moodle, see the video, and just redo whatever I explained in the today's class. Also, I have some connection with Knime, so they gave us some promotion code, so you can get some good learning from their website. I share it later, but for today, we just do our first hands-on experiences in Knime.
Professor, I have a question.
Sure.
You just mentioned just now before the video that on our papers, you don't want us to say that this caused this, or
Yeah.
XYZ, is a result of this. Do you want us to instead talk about the fallacies and other things that we find, or is it just like something that we would say, this is the result, but there could be a lot of other factors that also influence?
Yes, you can talk about it's a design. There are other factors that might influence, but let me give you an example. Let's say you want let's say your problem is that you want to predict someone's survival after a surgery, let's say heart transplantation. So I and you end up saying that blood pressure or BMI or let's say height are related to how long they survive more.
Mm-hmm.
So we don't say that BMI, blood pressure, or height cause somebody to live longer, but we might say these are the variables that are associated or correlated to lengths of survival.
Okay, perfect. Thank you.
You're welcome. But there is some course, a statistical course. I think you can find some YouTube videos or do your own search that they talk about how to find, how to investigate causal relationship. But again, it's not the focus for this course. Okay, so hopefully by now you downloaded all of the files and you already installed Knime. So having said that, from your downloaded files, go to ml_project1.knwf. KNWF is a file that we use for saving the workflow of Knime. So if you double click, okay, you might see a very crowded sheet, but no worries. I mean, we just go them one by one. First of all, there is two ways of learning a software. One way, just learning each section or each module, and then you learn all of it, but at then you may or may not use all part of a module. And also you don't have a big picture of what is going on. The second way, I mean, we look at the big picture, like here, this is a big picture of a workflow that might be even your final project. And based on your own specific need, you can focus on each section or study the modules by yourself. Same if you get my Python or Hadoop courses, it's like I'm telling to give you first show you the big picture, but based on your specific need uh, that's related to your project, you may focus more and just go in depth of those sections or modules. And again, there is so many softwares right now, like R, Python, Knime, and they have so many subsections. So, and for when you in future when you get to a job, you cannot memorize everything from every details from every I mean programs, unless you should learn how to approach the problem, knowing what is the big picture, and you need to modify based on your own needs. Okay, so as I said, this is the workflow or the big picture of what is going on in a prediction. But and also in the next classes, I give you other workflows, and you can just adjust based on your own project. So we also, if you look at the downloaded file, we have some Excel files. Uh, One of them is car sold update. So if you just open it, I have a brand, color, produce, price, sorry, data production, price, owner, is there user price, used or new, and if they're sold or not. So my final goal is having this independent variable from column A to F. I want to predict if we can sell a car or not. What can we do? What we will do? We make an artificial intelligence based on a machine learning algorithm, and we learn from our data and try to predict the column G. As you see here, we don't have the we have the car brand and color, but we don't have the the country that those brands are originated. If you open another one, which is cars brand state upload, you see we have the brand name and the country that these brands belong to. So maybe we can use this extra column, which is a state, add it to car sale, and basically make more information for prediction. So usually, if you add more independent variables, so one of them could be country, you have a better prediction. It's not always the case. And even sometimes if you have too many columns, we try to filter some of them out. But generally speaking, more information could be helpful for prediction. So it's the reason that we try to add another column here for the brand countries, the country that those brands belong to. And at the end, we are trying to predict if we can sell them or not. This is the big picture. So what is the goal? Let's say you are a car dealer, and based on your historical data, you want to see if you buy a new car, can you sell them or not? So the goal is training an artificial intelligence to learn from our historical data, which is under called sort upload, then use it for future use. So let's say you're a dealer and you have some customers, you want to decide, do you want to buy those cars or not? So if you buy those cars for your dealership, can you sell them or not? I also have another data, which is new underlying data. As you see, now I have car information, but the sort column is empty because I want to predict. Let's say this is a new information. I want to predict if I can sell them or not. Any questions so far? I think it should be very straightforward. So we have some historical data. We want to add some more data to that data, train an artificial intelligence, and use it for future and try to predict what could happen if we get some new cars. Okay, look at the left side. I have a data entry section. And as you see, it has Excel Reader XLS. So I show you some historical data and which are in Excel format. Now I want to bring it into my workflow. So let's click on the first one. So again, there is some other details, but we just want to get it done. So we just look at the default values. But again, as I said later, based on your project, you might change some of these defaults. The only thing that we want to change for today, you browse to the file that you downloaded. This is car brands estate upload. Car brands estate upload. So look at the bottom one. It's like a new Excel. I have a brand and state, and you see for each brand, I know the associated country. Okay. Look at the bar under that module is still yellow because we just define configurations, but we haven't run it. In order to run this Excel reader module, you need to right click and press execute. Or as you see, F7 is a short key for running a module. So I click. Now the bar changed to green. Same for the other Excel file. I click open. Now I browse to the car sort update. I browse on my system. Car sort upload. Again, at the bottom, you see what I'm uploading. Click OK, right click, execute. So as you already saw, one of them has selling information and the one has the country. Now I need to join these two tables together to basically make a larger table that has both information. Similar to database courses, you need to join these two tables. The logic is kind of similar, but just for your information, let me show you. Can go to Yeah. Okay, so we have four general types of joining. One is inner join, left join, right join, outer join. If you haven't had SQL course or database course before, for your project, most likely you do inner join. You don't work with the remaining. Look at my data. One of them is user table. I have ID 1 to 5 and the usernames. The right table, I have likes. So user ID and their likes. As you see, I don't have ID of 6 in my user table, and also I don't have ID 2 and 5 for the likes table. When I do inner join, based on the ID, so the common column is ID column with two different names, but they're actually the same. So my join now has just 4 rows because it's exclude number or ID 2 and 5, which is not common, and also ID 6, which is not common in this table. So now I just have 4 rows. When I do left join, I keep everything on the left table, but join the common part on the right table. So as you see, I have Patrick, Albert, Maria, Darwin, and Elizabeth. I have all of them. But I don't have rugby from likes because in this right table, this part is not common. So this row is excluded. If you look at the output on the center, for Albert, I don't know what they like, what kind of activity or topics they like. Or also I don't have for Elizabeth because all ID 2 and 5 is not available on the right table. But since I did left join, I keep everything on the left and just attach the common part in the right table. Same for right join. Now I just keep whatever on from right table, and for the left table, I just keep whatever that their ID is common. So again, as you see, I have rugby, but I don't have username because rugby is with user ID 6 is here, but I don't have ID 6 here. And the last one is outer join. It should keep everything from both tables, even if they don't have the common part. For example, for rugby, I don't know what is the user name. And for Elizabeth and Patrick, I don't know what they like because I don't know the user ID from the right table. Hopefully it makes sense. Again, if it's confusing for you, I assume you are from different backgrounds. Usually you should use inner join, most likely. For your project, you use inner join. Okay, let me go back on Knime. Now I'm doing the joining. If you double click, what was the common part in these two tables? One of them, okay, by the way, after you're running, if you want to see the outcome, you right click, come to output table. So what is the common column in these two tables? Again, let me right click the second one. And
brand.
Yes, I have brand, which is a common column in both of them. So when I want to join, let me just double click. So when you double click, you get to the configuration. I just say from left table use brand, right table brand, and just to inner join. Click. And for running, you can press F7 or just right click, execute. Then to see the outcome, right click, go to the join table. Or usually the last item is your outcome. As you see now, I have new column, which is state. Let's say now your project, you want to use a CSV file and you don't know the module, which is very okay. Even I don't expect you to memorize all the modules. You have two ways of doing that. First is you can Google it, like how to import CSV into Knime. Usually first two links. Here they're saying for importing CSV, you need to have a CSV reader. In many cases, you can drag and drop into Knime. Sometimes it doesn't have, but some of them have the active module that you can drag and drop. But at least here we learned that we should use CSV reader. Let me see. Yeah, in some of them they give you a module that you don't have to even search. You can just drag and drop. Let me see. Anyway, no worries. So let me go here. So I know that for importing CSV, I need to use CSV reader. You can either check on this one, go to each section and find it. For example, I go to IO, read, then I found CSV reader. I can double click here or just drag and drop. Let me delete. Or you don't even know, you don't have to know the subsection to use it. There's a search bar here. Just type CSV. Now you have CSV reader, drag and drop. And instead of using Excel, you can do configuration and browse to a CSV file that you have on your system. For example, these are my CSV files. So again, I don't expect you to memorize all of the modules, which is like not fair and it's not practical. Even in future, you don't memorize it. Usually you search and find the module that you need. Let's say later, based on your project, you need more details. There's a help button here for each module. Then you double click, it gives you further details about the module. What kind of changes that you can do. For example, what does join mode means here, or they are talking about all types. They are not talking about join columns and other sections. Now I give you some extra descriptive statistics activities, or you can do on your project. It may or may not necessary for your project. It depends, but I'm just showing them. So again, you don't have to use these extra descriptive modules that I'm covering now. It really depends on your project. You can even exclude, or even you can include more. Maybe you need other modules to be included in your project. You can Google for a certain module and see how you can use them. One of them is row filter. Let's say I want to filter out some of the rows. By the way, let me tell you how to connect them. Let me just delete this connection. Oh. Let's say I import row filter, and now I want to connect to the outcome of the previous section. Look at this black triangle. You take your mouse there, drag, and take to the next black rectangle from bottom, and you can connect. Let me double click. Here, I'm just saying that from column brand, include alpha, or I might say exclude alpha, or you can include based on row numbers, exclude based on row numbers, or row IDs, which we don't have it here. Let me click, execute. Then I go to the almost last item, which is filtered. And as you see, I just have alpha because I just said include from brand, just include alpha. Maybe I can just select exclude. Right click, execute. If I now go to the last icon, I don't have a brand of alpha, just beta and gamma. Let's say here in the join table, you are not happy with the order of columns. You can just change the order. For example, you can put the brand in the first one, sort in the last one. So how to do, there is a module named column sorter. It may not even necessary, but just as example, double click. I go here. So I have brand, state, color, produce, owner, maybe produce date. I just I select, and here I just select up, up, up. My first column is date. Maybe brand, I want to go to the last, put in the last column. I select move last. So my brand is now here. Maybe again, I click on sort. And again, instead of up, I just click down, down, down. So these are just for changing the order of your columns, may not even necessary. So I click, right click, execute. So after this bar gets green, I go to the last one, which is output data. As you see, sort is last one, produce date is the first column. Maybe you want to.
Professor, I got a quick question.
Sure.
So in my data entry part, it says Excel Reader, XLF, and then underneath it says deprecated. I don't really know why it says that. Do you know what that is?
Okay, so deprecated means in the new version, they have an updated module. So here you see deprecated.
Yep.
Okay, it just means the module is updated, but it's not in your workflow. So you can just search for Excel here, drag and drop the new one. So if you drag and drop, is it still deprecated? I don't hear from you, but it shouldn't be. So if you still have those issues, just let me know. But Knime frequently update the Knime. My Knime is for last year, so it might be you're using my 5, so it might be the reason you see some of them are deprecated. But you can just use the new version. So let me
Professor,
upload.
I have a question. I had the same thing with deprecated being there. Does it matter if that the Excel reader, if I dragged it over from the list, it's not in that data entry column? So in the yellow box?
Yeah, you can use the new version. So let me update my Knime. So if I not update my Knime, because you just download and install it, so maybe for me, many of them gets deprecated. It just means I'm using the older version, and it shouldn't interfere with your project.
Oh, okay, gotcha. Thank you.
No.
Yeah, thank you.
No. Okay, let me go over group by. Again, let me, at first, all of them are here. So I just want to group by based on maybe brand and let's say color. I select here, click on this arrow, drop it here. Okay, right click, execute. Then right click, last one, group table, and you see now it's grouped by based on brand and colors. For example, what based on the brand, which colors do we have? These are some general statistics. You can just for your project, maybe you can use it and just talk about your variables, which kind of variables you have, and like later I show you some more statistical summary. Anyway, when I'm just these modules for introduction, you may or may not use it for your project. The last one here is a pivoting one. So let's put it here. So I want to do pivot table based on brand, and the pivot column is color, and also the aggregation one is based on price median. So you can just change it to like minimum, like mean, or other aggregation function that you want. The way that is named, just put the pivot name and aggregation name. And aggregation, sorry, the column name and aggregation name is just based on method and color name. So again, if you haven't used pivot table, that's okay. I just want to show you how to use it. Click OK, right click, execute. Then after execution, if I go bottom pivot table, you can see based on different brand, what are the like median prices. So for each brand and color, what are the median price for each like intersection of these two? Like here, the cheapest median price is for green color gamma car with the green color. It's just 15,000 as a median price. The most expensive one, it seems beta, which has blue color as the highest median. Any questions so far?
Yeah, I actually just I missed that step to get pivoting to work.
Pivoting is a way of summarizing your data. So I'm just saying, like, I'm not sure if you already worked with the pivoting, but basically, I want to group based on brands, and each brand, I want to look at the colors. So brands for different brands, I want to look at the colors, and so, or maybe you can say my row, if you haven't used pivoting before. Let's say you want to have a summary table. Your rows are brand, your columns are colors. So, but what is in each cell of the pivot table? It's just the median price.
Yeah, I saw where I made my error. I had in the group the same thing. I had color, I think, in like both, and that's why it wasn't working when I tried to hit OK. But yeah, no, I think it's all good now.
Okay, that's great. Okay, so let's just keep this descriptive up here. Now, focus here. Again, after joining these two tables, so I made an extra column. Now, even you can make some extra column by some math formula. For example, here, if a price of a car is more than, let's say, some certain value, we might say this is a high value car or is a low value car. So if you click on here, as you see, for column list adjusted price, the reason you make formula over numerical values, and my price is the only numerical values. The reason here just have price, and here there are the functions that you can use. I just put all to see all of them. So look at here. I just said if price more than 20,000, consider 1, otherwise 0. Here, 1 just means high value, 0 means low value. But again, the formulation should be in the mathematical form. Maybe instead of that, and again, I said append a column. I don't want to replace any column. I just want to add a new column that has indicator for if its price is more than 20,000, it would be 1, otherwise 0. If I'm not happy with this, maybe I can put logarithm of price. And instead of price evaluation, price logarithmic value, or any other function that you're interested in. Let's just keep the first one that I just created, evaluation, and keep the formula that I had. Again, based on your project, you might use different formulas. Okay, right click, execute. If I right click, go to the output data. Now I have a new column, price evaluations. Look at the price. Here is 11,000 or near to 12,000. So indicator is 0. But for this one, 54,000 is 1. Let's do more statistical report. One of the columns, one of the modules that helps you do statistics, descriptive statistics is just statistics. So I use all the columns that I want to do descriptive statistics. Let me just first, all of them are here. I just said, let's just use all of them. Or you can select each of them that you're interested. Please, okay, right click, execute. Then if you look at the statistics table, price and price evaluation are the only numerical ones. It's the reason you have max, mean, standard deviation, variance, skewness, kurtosis, and all the else. For, let's see, yeah. Also, you can see them in this table format. So descriptive statistics is just for numerical value. You can also use box plot. I use box plot module, execute. Then if I go to view box plot, so this one is in the center. So if you forgot what is box plot just show first quartile, like second, third quartile, median. For price evaluation, it's just 0 and 1, so the shape is not that much cute here. So as you see here, I don't have anything to filter out price evaluation. What can you do? So having said that, this is my price like box plot. And if I'm not happy with this price evaluation, I can come over column selection, put it there, and just have price for my box plot. Or if you have more numerical columns, you can just select whatever you want. Or can anyone tell me on top of this section, sorry, on top of this section that I can exclude some columns? There is that. Is there any other way that I can exclude price evaluation to show here, to be shown here? It's actually column filter. So if you had a column row filter here, but there is another module for column filter that you can exclude some extra columns, which no worries, I forgot it's not here. Later I'll show it to you. So the other one is the scatter plot. So I should choose my X and Y variable. So my X is price. For Y, maybe I can select brand. Click, okay, right click, execute. Let me right click and select image. It may not helpful here because my brand is just categorical variable. Let's just select price evaluation. So here for brand, instead of brand, I select price evaluation, which is like showing if it's more than 20 or not. Right click, execute. Then right click and image. Now it makes more sense. Price evaluation was the indicator variable. So if 1 means there are more than 20, less than 1 means less than 20, which makes sense. Look at the 20,000 here. So If price evaluation is 0, means all of them is less than 20,000. Otherwise, more than 20,000. Now we can have a dynamic scatter plot. So with this module, you can have a dynamic one. So we just connect to the previous part of the workflow, right click, execute. Then if you right click and go to view a scatter plot, you can go to columns section and you just play with the variables. So you can select other different type of variables for scatter plot. But here, since they are mostly categorical variable, is the reason the shape doesn't look that much perfect.
Professor, I have a question.
Sure.
When I clicked execute on the scatter plot,
Mhm.
a red X shows up over the nodule, and it says no data available.
Have you run math formula?
When we did it before, yeah.
Okay, I should see your workflow. Let me just stop sharing. Could you share your workflow so I can see that?
Oh, it's on a different computer than I'm in on the Zoom.
Oh.
Sorry.
So my best guess is just you don't have some variables there, and like you try to make that box plot. So if you still have problem, please. I mean, when it's available for you to show me your desktop, please make an appointment so I can look at your workflow to see what is the issue. But like this way is a little hard for me to understand.
Okay. Do you have to execute the scatter plot local before you execute the scatter plot, the
No,
regular one?
these are independent. These blue modules are independent from each other.
Okay.
I assume you maybe you missed one variables for scat box plot. So might be, I'm not very sure.
Oh, maybe. Okay.
Okay, so please just redo the previous part. If you haven't, we can make an appointment. I can look at your workflow.
Okay, thanks.
Yeah. So again, as you go back to math formula, right click, add with data. Look at my produced date. It's just year, maybe month and day, and even it's not in the US format, and it's not actually cute. We can make it like extract year and month, and maybe make it cuter. We can use extract date and time fields. This is another module. If you right click, I'm just saying that, okay, my date and time column is in produce, it's automatically selected. I'm just want to get year and month. Maybe you can get week, or instead of month name, you can get month number or quarter. Right click, execute, then add to table. Now I have two new columns. One of them is year and the one month. Okay, having said that, we have a column for filter module that you can drop the columns that are not interested to you. If you double click on it, as you see, I said include this column and exclude state, exclude produce, evaluation, and month. I'm not interested in them, so all of them are in the exclusion part. If you later maybe you want to say no, I want to exclude year two, so you can drop year here, or maybe you want to say I want to put price evaluation back, so you can put it back here. And same for scatter plot or other figures. If you're not interested on some columns, you can use column filter before them and drop, or as we said, what was that? Okay, in box plot, some of them like box plot, you have a column selection part that you can exclude the columns that you are not interested. Okay, let's run column filter. The next module is not actually important, just for visualization. Let's say I'm interested to specify some rows based on some certain values. Let me right click. I just said from sort, everything which is didn't sell green. If I sort, yes. Let me run it. Right click, execute. Then if I go to table with colors, as you see, if it's salt is yes, green. If it's no, sorry, if it's yes, red. If it's no, green. And same for other. Maybe you want to play with the car colors. So instead of salt, I select color. Now, if I want to change the color, select the first one is black. I go to swatches. Then for black, I select the black color. For blue, I select blue. Green, I select green. Red, red. Silver, maybe something like this or this. Okay, so as you see, you can specify colors to some rows based on some certain values. So if I right click, table with colors, as you see, if it's silver, you see this color, blue, this color, red, this color, black, this color. As you see, there's not that much green, but there's a good amount of silver and blue, and somehow we have a good amount of red too. Okay, so far we call it data preparation. In next classes, I give you more extended workflows that you have good very details, and you see more modules for data preparation. But usually it takes like up to 70% or 80% of your time. And we haven't started machine learning algorithm yet. This part usually takes most of the time in your project. So if you might remember in the previous class, I talked about training and testing. So what we do, we divide our data into two sections of train and test. In the train, we train a machine learning algorithm. So it could be white box or black box. And we test that algorithm or that model on the test set. So we don't touch test set at all. We just do everything that we want on the train set. And then based on your model performance on the test set, you can decide if do you want to use that model for future or not. Also, I talk about cross-validation. But for today, we just look at a simple partitioning, which is just train and test. So if you click on partitioning, you see that I said 80% of my data should be trained and the remaining are in the test. Okay. Execute. Now, instead of one triangle, I have two. The upper one is for training. The lower one is for testing. And it divides my data into two independent sections. So you might remember in the previous class, I gave you some optional study for decision tree. And you can, here I use decision tree as my machine learning algorithm. And if you double click, I just said dependent variable is salt. I want to predict the salt column. And these are some internal tuning of decision tree algorithm. For other algorithms, the other section might be a little different. But for now, just keep it as default. So what does this module decision tree learner does? It goes over my trained data set, try to predict the sort column, and learn how to predict it. Right click, execute. So second part of the partitioning is for test set. Now I learn a model. I want to see how my model can predict the tester. So for this purpose, I use decision tree predictor. It has two inputs. One input is this blue square. It just inputting the model that I train. The second input is this triangle, which is my test. I right click and execute. Let's see what happened. I right click on decision tree predictor and go to classified table. Oh, sorry. Let me right click classified table. So as you see now, I have new column of prediction and solved. So solved is my actual column in the tested. Prediction solved is my predicted column. As you see for the first one, is I actually solved and I predicted as solved. For second one, is actually was solved, but I predicted no. So here, my model didn't predict well. Third one, true prediction. Fourth one, again, we solved it, but my model predicted as no. So there is always some errors in your models. We also need to evaluate how we are good, how accurate is our model. Could we accurate very well, or we have a big mistakes. So by the way, my dependent variable is solved, and it has just two labels, yes or no. If you toss a coin, or you just randomly do prediction without any artificial intelligence, do you think what would be your performance?
Long run, it would probably be about 50-50 for heads and tails.
Yeah. If you just use a toss a coin, your prediction performance is about 50%. So if you use the algorithm and my accuracy is 40%, it means I waste my time. I use so many modules and did so many data preparation here. But if at the end my accuracy is less than 50%, means I waste my time. Or it's much better if my accuracy is more than near 100%. It means I did really good job. But the bottom line, I shouldn't be less than 50%. It's too bad. If I'm close to 100%, it's really good. So here by now, we just did prediction. Now we want to look at performance of our prediction, how accurate we are. So we use a scorer module. If you double click, you just need to say first column is the actual value. The second one is the prediction value. And we just want, with these two parameters, we can look at the accuracy of your model. Okay, right click, execute. It gave me there is some missing values. So let's see what is my confusion matrix. Okay. It seems I had some missing value, but let's look at the confusion matrix. So you might remember how I talked about accuracy and basically sensitivity, specificity, recall. Let's look at last bottom, which is flow variables. My accuracy is 79 here. It's not too bad, it's not too good. But accuracy is much better than 0.5, which is 50%. For improving your model, you might have different things. Maybe you add in the math formula, you add some, generate some more columns. Or here in data entry, maybe instead of just the origin, maybe you need to add more data. Or maybe you use another machine learning algorithm. Here I use decision tree. Maybe I want to, you Google and you see that there's other algorithm like SVM or naive-Bayes. So last class, you might remember I talked about some of them. Let's just here in the search button on the bottom left, I search for SVM. Instead of decision tree, maybe I drag and drop and use SVM tree. And here, I just said predict solve. here we don't have time, but in your final project, I expect you to try 3 different ways to improve your model. One of them is just using a new learner. So here, I'm using SVM, which takes a lot of time. Anyway, you got the point. So based on, let me go to your lecture, and I think one place I talk about different algorithms. Let me see. Oh, this is your lecture. Now, these are different learners that you can use, like Bayes, genetic, support vector, neural network, decision tree that we use today. Or there are actually more than that. So far we did a lot of effort to do data entering, data preparation, and learning a model. And we want to use it for future use. For example, if you're a dealer, you want to see how you can use it for future use, how you want to predict a new car, and you see if you could sell them or not. For future use, we need to save our model. The module that lets you to save it is PMM Writer. I'm double click on it. So it just has a browse section. You go to the location that you're interested in. Instead of PMM.pmm, let's just put car sale underline cars underline sale.pmml. Save. With that one, now you can save it for future use. So later, you don't have to make those kind of data preparation, everything, to be able to do predict. Now, when you save this workflow or the outcome of the workflow, later you can easily use it. We have a little time left, so let's like now next week. Let's say we spend 1 more week. Now you are a dealer and you want to evaluate if you want to buy new cars or not. If you buy them, could you sell them or not? So from Moodle, there's another workflow, which is PML car predict. Double click on it. So it has 2 sections. First, it reads the model that you already created. I double click, browse to my folder, downloads car sale. It's the model that I already trained. For Excel file, I'm loading new data. So as you see, this new data that I uploaded, I don't have any sold column because I'm not sure if I can sell them or not. Click. So output of the Excel reader goes to PMM predictor, and also output of the PMM reader goes to the PMM predictors, blue to blue, black triangle to black one. And just keep it as default. So as you see, I haven't executed Excel reader and PMM reader. If I execute the PMM predictor, it automatically executes everything before it. So if you select any module and you right click execute, it executes that module and everything before it. And with data to report, I can see what is the outcome of my predictions. Again, just keep it as default, right click, execute. Okay, now I'm looking at table view. So on data to report, I right click, table to view. Now I have new column. My model that I already trained, I'm selling that. If you buy first car, you cannot sell it. Second car, you can sell. Third car, I cannot. So if you're a dealer, you know which cards it's better to avoid because you cannot sell them. Okay, this is the new data set. Do you think I can check over the prediction accuracy here? So, or I have prediction column. Can I understand what is my accuracy right now? If you give me the answer, I give you a really good bonus.
I mean, maybe, but I don't think that 7 observations is enough to really draw any conclusions.
Okay, so look at this scorer. Thanks for your answer. So in a scorer, here it doesn't show. Let me just delete it. What was that? So I have to open my previous PM. In a scorer here, oh my God, I should run everything, I guess. Okay, anyway, so when you want to look at the performance of your prediction, you should have the actual value too. Here, this is the new data. I don't have the actual value. I want to make a decision. So I don't have the actual value to compare with my prediction to find accuracy. You can look at the accuracy in the historical data, which we had in the previous workflow, but not for future data, because for future data, I'm not sure what happens. So we just use it for decision making. So, and if you might remember, my accuracy was near 80%. So I'm hope that, although I'm not sure what could happen in future, but based on the model that I trained, I'm 80% sure that these predictions are correct. Anyway, that's for today. Again, it might be a little confusing for you, but no worries. We have more hands-on experiences and we go over more expanded workflows. But the general thing, you don't have to learn each module in details. You just need to understand the general workflow. And basically, if you get the general workflow, you can easily search to see which modules that you can use, and basically do your own project. But later and later, we have more workflows, and I show you more modules that help you to understand it very well. Any questions? Okay, so let me show you a scorer again here. So for a scorer, I have first column, which is actual, second prediction. But when you're doing future, you don't have the actual value. You just have the prediction. Anyway, if there's no question, that's for today. Thank you very much and have a good rest of the week.
Thank you.
Thank you, Professor.
Thank you.
Thank you, Professor.
Thank you, Professor.